Topic 3 is operations on polynomials. This topic is going to have two objectives. The objective 1 that I'm going to cover in this video is going to be multiply linear polynomials to get quadratic polynomials. I'm going to do an example and have you pause the video and try your own. And I'm going to do an example of a different one and then have you pause the video and try your own again. Alright, to begin, first example I'm given is 2x times negative 7x plus 1. If I were to multiply this together, I would use what's called distribution. Before I do that, I want to note that this form that this quadratic function is in is called factored form. So I'm going to make note of that. It's important to start recognizing the different forms that quadratic functions can exist in. This one is called factored form. Another way I think of that is it's in pieces. One factor is 2x, the other factor is negative 7x plus 1. It's grouped together, that one is. So, factored form. I'm going to take it from factored form and get it into standard form by multiplying it back together. Alright? And the other word I'm going to use for multiplication in this case is called distribution. So the first step I'm going to do is distribute. In order to do that, I'm going to take the first factor, 2x. I'm going to draw my multiplication rainbows, or archways, pathways. There we go. So I'm going to take 2x and multiply it by the first term in the second factor, negative 7x. That is, now if you remember from Algebra 1, or even before then, I first multiply the coefficients together. 2 times negative 7 is negative 14. And then when we multiply variables together, if you remember exponent rules, they each have a power of 1. So base times base, or x times x, you add the exponents. So they were just an x to the power of 1. Now it's going to be negative 14x squared. 1 plus 1 is 2. So when you multiply variables, you add their powers together to get the final amount of variable that exists. Next part, I'm going to distribute back to the first factor, 2x. I'm going to distribute that into that second term of the second factor, 1. So I'll write that work out as well. 2x times 1 equals. In this case, it's pretty straightforward because 1 doesn't have a variable with it. And so 2 times 1 is 2, and then you bring along the x as well. So at this point, I have distributed this factor into the beginning of standard form. Now I'm going to write it in standard form. Step 2, and my final answer is negative 14x squared plus 2x. I put plus because 2x is positive. And I'm done. Pretty straightforward. If you would, go ahead and please pause the video and try number 2 on your own, and then unpause it to check your work with mine. Alright, at this point you should have paused the video to try number 2 on your own. Here's the work I've shown for number 2, and I've squared in my answer. Please check your work with mine. Now, one thing I want to point out in step 1, the distribute process, or the distribute step, 6 times negative 7 is negative 42, right here. But then, remember, x squared times x, you add the powers, so 2 plus this 1, because if it's not written, you can assume it's 1. 2 plus 1 is x to the third, or x cubed. And then my final answer in standard form, it goes from highest power to lowest power, so it's negative 42x cubed minus 6x squared. If you did not get that, please check with a neighbor or raise your hand and I will come check it as well. Now, the second one is a little bit different. Alright? If you notice, the main difference is I'm now multiplying a binomial by a binomial, where before I multiplied a monomial, 1 term, by a binomial, 2 terms. So, this process, the first step, I'll still write though. We're going to distribute. And if you notice, it's still in factored form. So I'm going to label that as factored. Well, wait a minute. I want to give myself a little room to back. Factored form. So I'm going to multiply the factors together to go back to standard form. Right. Distribute looks a little different because, again, that first term has two terms, so I have to distribute both of those terms into the second factor. So the first thing I'm going to work with is the first term, the first factor. I'm going to times that by the first term of the second factor, so I'll show that one. And this is step 1. So I'm going to do negative 8x times negative 4x. Alright, that math, negative 8 times negative 4 is positive 32. X times x becomes x squared at the top. Then I'm going to go back to the first term, negative 8x, and distribute it into the second term of the second factor. So it becomes negative 8x times negative 3. Negative 8 times negative 3 becomes a positive 24. And I bring that x along to the right because negative 3 did not have an x. Alright, I'm done with the first term of the first factor, or binomial. So I'm moved to the second term now, the 8. I'm going to distribute that into the first term of the second factor. So 8 times negative 4x. Keep in mind, I'm bringing the negatives along for the ride, and even like this minus 3 up here, that becomes negative when I do the math. So 8 times negative 4x equals negative 32x. And then finally the second term times the second term, 8 times negative 3 gives me negative 24. No x is in either of those. So that process again was first term times first term. So first term times first term times second term times first term, second term times second term. Now that's the distribution term, okay? The only main difference here is it has a step in between distribute and write in standard form. In this case, I'm going to have to combine like terms. I'm going to write this in a different color so you can kind of see what I'm doing. Combine like terms. Alright, so in this case, I have 4 terms to work with. 32x squared, 24x, negative 32x, and negative 24. Now, what makes a term alike is the power that it has. So if you see a term that has the same power, they are alike, and you have to combine them together to get one final term, specific term of that. So if I look at 32x squared, of the other 4 or other 3, no other term has an x squared. So 32x squared does not have a like term. I do notice, though, that these two middle ones, 24x and negative 32x, the x's both have a power of 1. So they are alike, which means I have to combine them. So I'm going to add those together. Now, 24 plus a negative 32 is a negative 8. So I'm going to put negative 8x. That's the x of the linear term. So I used to have 24x and then a negative 32x. Those combine together to give me negative 8x because 24 plus negative 32 is negative 8. So I have just done step 2. There was only 2 terms to combine. Now finally, step 3 is the same as before. Write in standard form. So, step 3, I'll do it down here. My highest power is 32x squared. Then my combined terms, linear term, is minus 8x. And then finally I have a minus 24 right here. This is a quadratic trinomial. Trinomial because it has 3 unique terms. And I'm done. So, I'm going to ask you to do number 4. Go ahead and pause the video, take it step by step. Step 1 is to distribute. Step 2 is to combine like terms. Step 3 is to write in standard form. Step by step, and get me a standard form quadratic trinomial is what you're looking for. So please pause it and try number 4. At this point, you should have paused the video and tried number 4 on your own. I've done step 1 here, step 2, and step 3. My final answer is negative 6x squared plus 6. So the factored form was given to you. The standard form is the answer that I got. Please note that in step 2, I had a positive 6x here, a negative 6x there. So when you combine those together, 6 plus negative 6, they cancel each other out. And so that's why I wrote 0x, because I end up with no more x terms because they canceled each other out. But I don't have to put 0x in my final answer. So if there's ever a 0 term, you don't have to write it in your final answer. So if you did not get that, please check with a neighbor, or please raise your hand and I will come by and check your work as well. And now, if I ask you this question in class, please, and you can raise your hand right now if you would like, so we can discuss it, but this is a big concept here. When you're multiplying two linear factors together, what type of function do you get? So if you multiply two linear factors, which we've done twice, what type of function do you get? Thank you for watching.